And let's get started. Cool. So today we're taking a second look at HTTP specifically. So before we get started, can anyone tell me why we are talking about HTTP again? Like, why HTTP? Why spend an extra day on it?
For secure?
Okay, for security. Yes, but we'll spend time on other protocols too. Like, why aren't we spending time on like FTP or like stuff like that? Like, what's special about HTTP? What makes HTTP kind of special for us?
It's used a lot.
Yeah, it's used a ton. It's like almost synonymous with the internet, right? In fact, like it's so huge. It's like one of the largest protocols used for transporting data. If you plan on taking your OSCP, there's a good chance you're going to have to hack some boxes with a web server that's running HTTP on it. I would say there's 5 boxes. You could assume probably like 2 or more are going to have a web server, and it's likely that that's going to be the way in. So let's talk a bit more about HTTP. What makes it so special? Let's see kind of like how it's evolved over time to be the beast that it is right now. So what are we going to talk about? We're going to review HTTP. What have we talked about it before? We're going to talk a bit more about the request and response structure specific to HTTP. We're going to talk about the different types of requests that you can make. We're going to talk about the response codes, whatever those are. And let's get to it. So HTTP, I'm going to tell you this, and I want it to stick to you. HTTP is a protocol that has one request and one response. You can only ever have one request to one response, okay? Never ever can you have a server that responds 2 times, okay? One request, one response only. In fact, one of the most common bugs, I've definitely written this before, when you're writing some server code, is writing code that will make 2 responses. You can't do that, right? Like, it's just not part of the HTTP protocol. Those are the rules. If you get one request, you can make only one response. Now, you might have to do several things to generate that response, you know, just like when we were looking at DNS before. If I make a request to a DNS resolver, the DNS resolver might have to make several requests to other DNS systems in order to get the answer to me. But the point is, I made one request to the DNS resolver. I only get one response back. Okay. So for HTTP, let's take a look at what this request looks like. Okay. So at the top, we have the header right there. So it is a post to /books, and it tells you the protocol. The top right there is the verb, the URI, and the protocol. So the verb is post, right? I'm going to make a post. The URI is the unique resource identifier. So this is the /books off of www.test101.com. So we're making a post request to www.test101.com/books over HTTP. And then, so you see the verb, the URI, and then below that you have all of the headers, right? We have the host, we have what types of data we'll be accepting back. We're accepting images and GIFs and JPEGs and everything really. What language we're working on, so English, US. What types of encoding we'll accept, and the user agent. Who am I as I'm making this request? What browser is making this request? And so it says Mozilla, and off of a Windows machine is making the request. And below that, where it says book ID equals 12345 and author equals Corey and content equals this is a story. Below that, that is the body of the request. That is the body of the request. And that's generally the data. And that's going to be the part of the request that is encrypted. If we're talking HTTPS, okay? So there's 4 common verbs when we're talking HTTPS. There's more than this that are used, but there's 4 really common ones. And, you know, it's the 4 common ones that you have for pretty much every computer application. You have read, create, update, and delete. CRUD, create, read, update, delete. And the verbs for them are get, post, put, and delete. Okay. Now they're just a set of standards. I don't have to follow these standards. You know, I can make a post request that the server interprets and deletes something, right? Like, no, these are all just standards that people are supposed to follow. That's my point here. But generally, people are following these standards. If you make a GET request, it's give me this resource. I'd like to just read from it. If you're making a POST request, I'm trying to add something somewhere, create something, add something to a database. Put, I'm trying to update something. And delete, I'm trying to delete something. Okay? So let's talk about GET requests. They are the most common kind of request, and it's really just a request to read content. Your browser is constantly making GET requests. They're really simple. They're just like, hey, please give me this resource. I'd like to read it. And it's the one we can control with our browser when all you do is put something in that URL bar. When you put something in that URL bar, it is only a GET request. So when you go to www.google.com, you're saying, I would like google.com. Please let me read that resource. Right? This is really important. There's no body in a GET request. Okay? There's no data part of the GET request, no body part of the GET request. There's just the verb, the URI, the protocol, and some headers. That's all it is, right? No body for a GET request. I would just like this. Proper authentication and authorization might be important, or it might not be important here, right? When do you think it would be important? When do you think it wouldn't be important? Someone give me an example.
If you're trying to access some sort of, I don't know, open resource, authentication may not be important, but if, you know, you're trying to get your 10th article of the month from New York Times, it would be important. Yes, absolutely. Oh man, and great example, right? So GET requests, sometimes it doesn't matter, right? Anyone should just be able to get some resource. Everyone should be able to go to the homepage of google.com or to your, whatever your web app is, right? But not everyone maybe should be able to go to, you know, see your profile on Facebook or something, or see your profile. Okay. They only can provide information through 2 means. So like I said, in a GET request, there's no body. So there's only 2 places you can put any information if you'd like to add some information to this GET request, if you'd like to add some context for what you're doing. So there's the path, right? So if you go to somesite.com/shirts, that means I'm making a GET request to the /shirts resource. So please give me information on /shirts. Otherwise, and you've totally seen this before, these are called the query parameters. So if you go to your website.com/shirts and you see that question mark, and then you see some key value pairs where it'll be like size equals medium. Or if you've taken a look and paid close attention to when you're scheduling office hours with like me or Frank and you're like filtering down, you might see question mark host equals and then my last name or something, right? This is super common and you're going to see it everywhere now. But there you go. This is one way you can make GET requests that I'll actually send a little bit of information. And we'll take a look and look at some websites that are doing this, these query params. It's all over the place. It's like, you're going to see it all over the place now. Okay. Post requests, different kind of requests. This is for adding data. They have a body, okay? So it's a request to create content. So if you are creating a new account on a website, very likely you're going to be sending a post request. If you are adding a new comment on an article or something like that on Reddit, very likely you are using a post request to create that content. And all of the data associated with your post is going to be in the body, like your author, the content, any images maybe, I don't know, that sort of stuff. So it's very common in sign-up pages, forum posts, comments. Anytime it looks like you're going to be creating something, it's very likely you're using a post request to do it. Here, you're very likely going to need some kind of authentication or authorization, right? Not everybody should be able to post
comments on certain things, perhaps, right? Not everybody should be able to create an account. I don't know. Things like this. Okay. Post requests often rely on the path to designate to the server what kind of content's being created. So if I'm, well, we'll take a look at some examples, some real world examples in a bit. And the most important information about post requests are going to be in the body. That's really the major difference between them. The headers will pretty much look the same, but there's going to be a body. Okay, so let's take a look at what a post request looks like. This is just exactly what we were looking at before, but just with a bit more context. At the top on the first line, we have the verb, we have the URI, and we have the protocol. In yellow, we have the headers. And in green at the bottom, we have the body, right? So if we're making a post request to /books, I'm going to assume this is some request to add a book to this website, right? And if I look at the body, it kind of makes sense. It says, okay, book ID 12345. That sounds like some information that might need to be in the book database. It says, and author, right? So all the author of the book. And content. That must be the content associated with it. But just from reading this request, this is what I assume must be is going to happen at the back end of the server. Someone wrote some code to handle this. Okay, so major difference is you get a body in a post request. Okay, URI, verb, headers, body. Put requests. These look almost exactly the same as post requests. Their only difference is the context in which people decide to use them. These are for updating, but they don't have to be. Again, none of these things have to be. These are just rules that people have decided on. So it's very common if you want to log into a website, you're generally going to be putting in a put request, kind of changing your status from logged out to logged in. If you're updating your profile information, very likely you're going to be making put requests to update them. If you're editing comments, anything like that, very likely, if you look, they're going to be put requests that were used to do it. Again, same idea, probably should be using some kind of authentication and authorization in order to establish, like, yes, you are allowed to change these things, right? You don't want a situation where I am allowed to edit your profile information by putting in put requests. Right? There must be some kind of authentication and authorization procedure before that. And again, same thing that you had here with posts, right? We're often going to rely on the URI and what type of content to modify, right? So if I make a put request to /books, I'm probably going to edit something about a book. Most important information about the put request is, again, going to be in the body. Delete requests. Again, this is going to be a request to delete some content, get rid of it. Generally, not going to be a body for a delete request. You don't usually need a body. It's just say, hey, delete this thing. But like I said, these are not rules that are enforced by anyone. You can put a body on your delete request, and if the server is going to look for that body, maybe it'll do something with it. But generally, there's not going to be. Again, we're going to look at the resource. So if you send a delete request to /books /books/12345, it's probably to delete the book with ID 12345, right? And of course, authentication and authorization are going to be essential here. I should not be able to delete all of the books unless I'm allowed to delete all the books, right? I should not be able to delete your account unless I'm authorized to delete your account and I'm authenticated. Okay, so let's take a look at what the responses look like. So the other end, right? So I made a request. Here's what the response will look like. At the top, it's saying HTTP 1.1, so that was the protocol. And then you're going to get the response code. You can look these codes up. You don't have to memorize them, but you may want to memorize the numbers at the front. So like 200s, 300s, 400s, 500s, and have an idea of what those mean. But by memorizing them, I mean, you're just going to look them up sort of and learn, oh, 200s means things went okay. The server did what it was supposed to do and no sorts of problems. Then we can look at 3, 4, 5s, what they mean. But you'll also see we get some headers, right? The server attached some headers onto the response. It says what date, says what the server was, right? It says maybe when the content was last modified, right? What type of content we're sending to you. We're sending some text and HTML. And if you look down there, there's a body to this response. And in that body, that's the HTML. And it could be the CSS and it could be the JavaScript, could be other stuff. But that's the response. Any questions so far on the things I'm going through? And go ahead and just unmute yourself or let someone read it out in chat because I can't see chat.
Nothing in the chat.
Okay, cool. So again, looking through this, you have your status. That's important. We're going to look at those. We have our headers, and we have the payload or the body, right? So this is the anatomy of a response. So let's look at some common status codes. We have 200. This is the most common one. This is okay, right? Everything went well. If you get a 200 status code, good. 201, that's like, okay, we created something for you. So if you add a new post and it's successful, you'll probably get a response code that is 201. Like, good job, you created something. We have 304, which says something was cached. We have a 400 error, which was a bad request. You made a request that was not properly formatted for the server. It didn't know how to handle it, so it's telling you made a bad request. And if you take a look at 400, generally that means something went bad on the client side. Right? You made a bad request. You're not allowed to look at this. The resource you're looking for is not actually there, right? Or what you're asking for, we don't actually have that. That's not a thing, right? And then the 500 codes are something went wrong on the server's side. 500, some kind of server error, we broke. 404 is the most common error that you probably have seen before, right? You may have seen that on GitHub, you may have seen that on some page anywhere, but it means that the resource you were looking for, the server didn't have a response to that, didn't have that resource. And again, there's plenty of common codes. You're going to look them up. There's like uncommon and weird ones that people have added. There's code 418, I'm a teapot. This one actually does have some history behind it. I'm pretty sure this is when they made the coffee pot at, oh gosh, I can't remember what organization it was, but it was a way to check who is it,
Was it Caltech? You're talking about the webcam thing?
I don't know if it was a webcam, but essentially it was a way to check if there was coffee in the teapot or something like that. And so it would respond with the 418 status code, like I am a teapot. But again, not super important, and you can always look up these status codes. Okay, so big summary of the things we talked about. We have verbs that designate the context for a request, right? 4 big common ones, which are the CRUD ones, create, read, update, and delete, which is get, post, put, and delete. And it's the server's responsibility to actually do something with it. It doesn't have to, right? But we generally pay people decent money to write good server code that'll do things that we want. Servers respond with status codes as well as a response. Right? Usually they'll have a code that means something. 200 is one of the most common ones. 404 is one of the most common ones. We'll get a bit more familiar with all of them. And then we have the 4 major types of requests. Let's actually play with some stuff now with some of the tools that we're going to be using today. And we've got some cool hacker tools that we're going to use today. So. Okay. Here we go. Okay, so there's 2 hacking tools that we're going to familiarize ourselves with today. One of them you've already used before. So let's start with, well, both of them you've already used before. Let's start with the command line one. We're going to use curl. used curl before. Curl is going to be one of the tools that we're going to use today because we're talking all HTTP, and curl is a way we can send requests, HTTP requests through the browser. So we could curl example.com, right? And then I can get the page, but there's much more that I can do than just send regular GET requests. I could send different kinds of requests, right? We could do curl -- help. This is where I go to usually first for pretty much every command when I want to start to use it right away. And then scroll to the top and take a look at the usage. So it looks like curl. I can put some options in, and then I can give it a URL. So let's say I wanted to send a different kind of request instead of just a GET request. How would I do that? Well, I'd look at curl, I'd look at -- help, and maybe I would start looking around. -- help, that shows help. So this is one way that I can try and learn how to use a command like this. But the more common way, if I'm being honest, with commands that are very that are well known, like curl, is I could look through the man page, absolutely, but I like the man page in my browser a little bit better. So if I man curl here and look through this, I like this a little bit better, mostly because it has links like direct links sometimes right in here to documentation, which can be a little trickier sometimes if I'm just using the man page in my command line to navigate. It's also a little bit easier for me to Control F and search for things. You can do it in the man page, but I think for most of us, it's a little bit easier to do that. Okay, that's one way if I'm looking for curl and what kinds of things I can do with it. But that's not always the fastest way. If I know in general what I want to do, I Google it. And so, for example, if I wanted to say curl make post request, I'd Google something like that, and then I would look for examples. This is the fastest way to learn how to do things like this, right? So I would just find, okay, right, curl how to make a post request. Here, someone already shows me with different examples. How can I make a post request? How the body should be structured, right? All different ways I can do it with examples. So this is the way I go about learning how to use some of these tools. And I'm telling you, you're going to need to use curl, and I'm telling you how you would go about learning specifically what you would want to do. So that's the first tool we're going to be using today. The other one, the other hacking tool you're going to be using, and I'll show you a little bit more in depth how to use this one, is your browser. I told you guys before, browsers are really cool. They're one of the more powerful hacking tools you'll use, and we don't even realize it. So let's take a look at some things we can do with our browser. So the first thing I want to show you is if you go here and you go to under the web developer setting, you have the toggle tools. So Control-Shift-I, these are the tools that we've been using before. So what I want to show you first is the console right here. This is just like if you were to open up a terminal and type in like Python 3. And you see how you're in like a Python 3 terminal console right here, and I can do Python things like print hello, right? And it'll do Python things. Here's a console, but this is a JavaScript console. I can do JavaScript things in here because JavaScript's the language of the browsers and the web. It's slightly different syntax, right? Instead of saying print, they say console.log. I don't know. So that's one thing we can do. We can look inside here and we have a way to write some code in JavaScript. We can also examine the code that's here, right? When I told you we make requests and we get a web page, we get the CSS, we get the HTML, and we get the JavaScript. So that must mean that there's some environment where JavaScript is running here, which means there's variables, there's all kinds of things inside here, and we can look at it. So just like in here, if I make a variable, right, flag equals fs, here we can do it like this. So it even looks like our flag, right? If I set some variable to be flag, how do I look at the variable flag? How do I see its, how can I see its, what it points to?
Just print flag or echo flag.
Yeah, I can either print flag, right? And it'll just print it there. I could say flag, and it'll print it there too. So similar idea here. If I set some variable called flag, let flag equal fs, right? I can say flag, and it'll print it out for me. So that's kind of nice. Now, let's say I didn't have any idea what kind of variables are on here. I could go to view the page source. And I could take a look at what kind of stuff was put inside this JavaScript. So if I was just look in the JavaScript, I think there's some JavaScript here somewhere. Is there a link to another JavaScript page on this? Might not be. Anyway, I could follow where this adds, right? So if, it's going to be small. Let's see. Scroll all the way to the bottom. We see some random JavaScript here. See how it's setting some variables. Let's see if we can find that variable, GA. No, it's not. Oh, well, we could get this variable, GA global. We could get document dot cookies, cookie. That'll give us all of our cookies. You can look at those later. Cool. What else do I want to show you about this terminal? Clear. You see clear. If I type clear, it tells you what it is. It tells you it's a function. How do I invoke functions? How do I invoke functions?
You'd open parentheses, put something in there, and then close parentheses.
Yeah, so I want to run the clear function. Oh, nice. Clear out my terminal, clear out my console here. So that's one thing I want to show you guys. You can open up the console. You can look at variables that get put on here, right? You can look at anything that gets put onto this environment. Additionally, we also have, let's see, the network tab. Let's run this again. And here, you can see all of the requests that are being made. I want to bring this to your attention here. So again, I just went over to the network tab on your browser. I made one original request here. This was this first one. And we can take a look at this request. Everything I showed you in the slides are all right here, right? I could see the URL we went to. I could see what method it was. I could see the response code. It says it was 200, so the server was okay with that response, okay with that request. If I wanted to change this request, I can hit the edit button. And I can literally go in here and change anything that I want, right? I can change the user agent, so I'm not this user agent anymore. I can change who the host is if I didn't want to send the request there. I can literally go into the browser and edit the request before I send it, or after I send it if I want. Okay. We can look here at the params. There were no parameters for this request. I'm going to show you a request that has some parameters. We can look at the response. Here's the response, right? It's very nice that it lets our browser, it has our browser render it for us. So it's not just the raw response, but you can see it right there. Cool. Let's go to another website. LearnDot, I wanted to show you this. So I'm just going to go to LearnDot. Wow, you can see how many requests are being made. Look at this. Look at how many requests get made just to turn on LearnDot. Okay, if I wanted to go to office hours, what does it support? Office hours. Right, so the URL is learn.fullstackacademy.com/office hours, right? If you see here, this filter by name part, say I wanted to see Jackie, you change it. You'll notice it updates up here. And now says question mark host equals Jackie. Let's see, if I wanted to see someone else, let me see, I don't know who else is actually doing office hours. Jolie, okay? I could say question mark host equals Jolie, Jolie, should come out that I see her now. There we go, just Jolie. Okay, same idea if you go to websites, really common for shopping websites. So go to a closed shopping website. And we're looking for, I'm going to close this so that we can see some clothing. Pants and jeans, sure, sure. You notice the URI here, and I apologize that I can't make this bigger, but it's in /shop/clothing/pants, right? So this request here is going to bonobos.com and asking for all of the resources that get request to /shop/clothing/pants. So essentially I'm asking the server, give me all of your pants, and it's showing me all the pants here. But let's say I don't want to see all the pants. I want to see them, only the gray pants, right? Say I only want gray pants. So now it's making a request to the server again, and it's the same endpoint, /shop/clothing/pants, but you'll notice there's a question mark, and you have this key value pair now, which says base color equals gray. And now you'll notice I only, well, I don't know if this only counts as gray, but should only be showing me gray pants. Right, let's change the color. I don't know what other colors do they have here, just so I see. Brown, it's just so you see. If I change this to brown, the server should be okay with it and show me brown pants, hopefully. Those look brown, but that looks like the same image as before. Yes, these are kind of brown.
It's all the pants that come in brown.
All the pants that, that's right. All the pants that come in brown. Cool. I'm gonna find a better closed site that just shows the exact image. Okay. Anything else? Frank, can you think of anything I might be forgetting with the network tab?
Oh, no.
Nope. So
well, no, actually, the one thing, so in Firefox, though, the one thing I think you could show is that is this Firefox or Chrome?
This is Firefox.
In Firefox, you can right-click a particular, request,
yeah.
And then you do edit and resend, and then you can change the parameters and resend it and see it. Yeah.
Yes, right here. So you can see even here, right here, this request was the request to get that image that I guess were for those pink chinos. All right, you could send it again. There it is. Those pants are hot. You could see the parameters that get added.
Yeah.
Let's see. I want to see one. It's the original request. There we go. You can see the query parameters that were added. Base color, brown. If I wanted to change it, where's the edit and resend button? Where'd that go? Can't find it.
On the right, go to the headers.
Headers.
And there it is. Edit and resend.
Yeah, but it was the specific one I was looking for. I don't know where that request went now. These are all images for scripts. You could look here too. Encourage you all to like kind of play around with this too. If you decide to take a look at these in Chrome and use their developer tools, it's slightly different. And again, I encourage you to just kind of Google the differences if you're interested, but you should be able to do everything between either browser. And by that, I mean, look at the requests that are being sent, actually take a look at the raw requests, edit them if you want. All right. I think that's pretty much all I have to say about HTTP for now until lunch. So y'all know we're going to be working on CyberLab all day, which is great. The problems are going to be intermediate web. I'm going to ask you to skip Big Blue Muppet until after lunch. as well as OREO. Just hold off on those until after lunch. Oh, Frank, there's one more thing I got to show them about the web. Robots. Robots.txt.
Yeah.
Got to show you guys that. Okay. So there is a common file on many web servers called robots.txt. Let's take a look at one. I think FullStack has one. Gonna look silly if they don't. Cool. So it's a file that's gonna look like this. And essentially it's to speak not to users, but to web crawlers. And so web crawlers are essentially robots that go through the web and follow all the links and index things. They'll index things for search engines. So if you ever had a job in marketing and you did any kind of search engine optimization or anything like this, you may be familiar already with robots.txt. So this file that lives here, any robot, any bot that indexes the web, when it goes to fullstackacademy.com, it's going to check robots.txt and it's going to say robots.txt doesn't allow or don't check out these places. Please don't check out these places, robot. Now, robots don't have to follow these things. These are just like requests, like, hey, you don't have to check that out. Or don't index these things, right? Some of these things might not be wanting to be found on Google, so you might use a robots.txt. You'll find these all over the place. So Full Stack Academy has one. I know Facebook has a giant one for their, so everyone's just not getting web crawled, right? They're saying, hey, robots, don't go here. Try not to go here, right? Says, if your user agent is MSN bot, don't go here, or you're allowed to go here. Sometimes it says disallow, right? So that's the way that works. Just key value pairs where you're allowed to go. If you're Apple bot, don't go here. If you're whatever this user agent is, Baidu Spider, don't go here. Now, of course, you don't have to follow these things. If, whatever you want to do, you can go wherever you want, right? So if I wanted to go to Ajax, I could go to /Ajax. Let's see what it does. Cool. Well, it's not available to me. But you can. You can go wherever you want. So robots.txt I wanted to show you. Anything else? These, I think that's it. We've already shown you wget as a tool to download things off the website, off of the web. All right. So do we have any questions before we get to it?
Which two are we supposed to skip in the CyberLab to lunch?
OREO and Big Blue Muppet. I'll give you two guesses to what those questions are about, but we'll talk about them later today. Cool. Any other questions?